Welcome to MedHelp 24/7. Please rate, comment, and subscribe for future videos. Thank you. Alright, so today we're looking at a general introduction at alkenes, a special type of organic chemistry functional group. And today we're just doing a quick, brief overview. So, what are alkenes? Well, the alkenes have a very special functional group, and that is they have a double bond. And a double bond is made up of one sigma bond, and there is a pi bond. And so anywhere you see a carbon double bonded carbon, right away that's an alkene. So alkenes are obviously everywhere. This is a structure of 11 cis retinal. This is actually found in our eyes. It's a chromophore and it's a light absorbing group involved in vision. As you can see, there's arrows pointing to the double bond, so that would be an example of an aldehyde of an alkene. So alkenes are also unsaturated because they have less than the maximum number of hydrogens, and they also have the general formula. All alkenes, or linear alkenes, are CnH2n. So let's say you had C2H4, C3H6, you get the idea. Now, hybridization. Now, if you haven't done hybridization before, I do recommend that you learn that before organic chemistry. But for those who have, it's always an sp2 hybridized carbon because there's 3 effective pairs around the carbon. And the double bond, again, as I said earlier, it's one sigma bond and there's one pi bond. The pi bond is also formed from the overlap of 2 p-set orbitals, and the sigma bonds are formed from the head-on overlap of 2 atomic orbitals. Now, there's also a restricted rotation around that pi bond. Around double bond, there's no rotation. So as a result, there's 2 arrangements in space, and we call those isomers. Now there's a cis configuration, and then there is the trans configuration. The cis configuration is if they're on the same side of the carbon, and in a trans configuration there's substitutions on opposite sides of the double bonded carbons. So let's take a look at some examples to make this more clear. So let's say we have this molecule here. So this is also where, as you can see, you have the 2 methyl groups that are on the same side of the carbon, so that would be the cis configuration. Whereas if you look at another molecule, so as you can see, it's also relative to the double bond. Here, the methyl groups, the CH3 groups are on opposite sides of the carbon, so that's going to be the trans configuration. So that's the difference between cis and trans. Remember, cis is on the same side, trans on the opposite side. But let's take a look at naming. So how do we name alkenes? Well, it's very similar to naming alkanes in that you always find the longest continuous chain, which is the parent chain. You number the carbon atoms, and you name the substituents based on numerical priority. And you always want to make sure that the double bond always has a lower number because that has the highest priority. If you haven't done naming alkanes, that should be done first before alkenes. So let's take a look at this one here. So we got a 4-carbon chain here. If you look at it, 1, 2, 3, and 4. Now you always want to start on the side that double bond also has a lower number, but in this case, it's always going to be carbon 2 no matter what. So this is an example of 2-butene. But because it's 4 carbons, and ene because it's an alkene. For an alkane, we butane. Here's another example. So here we have the longest chain is going to be 6 carbons, and it's going to be the 3rd carbon as a double bond, and the substituent is a methyl group on carbon 2, so therefore 2-methyl 3-hexene. Why is it hex? Is because there's 6 carbons. Why is it ene? Because it's an alkene. And the reason why you put a 3-hexene, so that tells you where the double bond is. Here's another example. So here we have the longest chain is going to be 1, 2, 3, 4, 5, 6. That's going to be an example of 6 carbon chain, and there's 3 methyl substituents. So that's going to be 2-hexene, but it's also going to be, there's 2 methyl groups on carbon 6, so that's going to be 2,6,6 trimethyl 2-hexene, as you can see there. And why we have to put 2,6,6 is because there's 3 methyl groups, 3 substituents, and you do have to label. You have to write the number again if it's 2 on the same one. Now alkenes. Let's look at some reactions. Now there's addition reactions and elimination reactions. There's 2 main categories of reactions. There's many subtypes of each one, but they all have the same general pattern. So it's really important to understand the pattern, then you can apply them to this one. So what is an addition reaction? Addition reactions, we're adding a group to the molecule to remove the pi bond, but in elimination reactions, we're actually removing something, eliminating something from the molecule to form the pi bond, as you can see there as well. And all addition and elimination reactions will follow this general pattern for alkenes. So it's too hard to do all the reactions in one video. These are all the examples of 6 videos. I will have video links for each of these reactions below. They all have a slightly different mechanism of action, but the general product line is still the same as in the previous slide before. They're all addition reactions here, and there's also a few elimination reactions coming up here as well: dehydrogenation, dehydrohalogenation, and dehydration as well. And I will cover those. Links are in the description below. And yeah, thanks for watching. Please subscribe. Thank you.